All right. Hi, everyone. Welcome back to CHM421, which is analytical chemistry. We will continue our learning on the acid-base titration, which is topic 4A. So, in this video, we will discuss again on the acid-base titration. Acid-base titration is the experimental procedure that used to determine the unknown concentration of acid or base, unknown concentration of acid or base by neutralizing it with acid or base of known concentration. In another words is we want to determine the concentration of unknown of acid or unknown of base by using neutralization concept with a known concentration of acid and base. So there are four types of acid-base titration. Strong acid with strong base, strong acid with weak base, weak acid with strong base, weak acid with weak base. So we have four types of titration. Strong acid, strong base, strong acid, weak acid, strong base, weak acid, weak base. All right. So choosing a titrant. Titrant is a chemical in the borates. In theory, any strong acid or strong base can be used as a titrant. The reason for this is most of the reaction is involving strong acid or strong base is quantitative. So we have a few options of strong acid titrant or weak acid titrants. So it's listed in the table. Strong acid titrants are hydrochloric, nitric acid, perchloric acid, HCl4, phosphoric acid, sulfuric acid is a strong acid titrants. Over the weak acid titrants, we have a few options here. A strong base titrant normally is a hydroxide base chemical, sodium hydroxide, potassium hydroxide, magnesium hydroxide, barium hydroxide. Weak base titrant, ammonium hydroxide is a common example, or sodium carbonate also is a common example. Okay, so now we focus on the titration curve. Titration curve is a graph of pH versus volume of titrant added. The solution in the burette, we call it a titrant. So the graph of pH versus the volume of the titrant, we call it titration curve. So for strong acid, strong base titration, the equivalent point pH 7. The pH range is between 3.5 to 10, 9.5, 3 to 10. Okay, 3.5, 9.5. Strong acid, because this is a strong acid, strong base, a strong acid is strong base, so meaning that the pH is a strong acid, 3, strong base is about 10. For the strong acid, weak base, pH less than 7. Less than 7, it's more towards the range of strong acid. Okay, less than 7. So the pH change is between strong acid is about 3, weak base about neutral, 7. So weak acid, strong base. So we can predict the equivalent point because the strong base, it should be pH more than 7. So the pH change, a strong base is above 6. Weak acid is weak acid, it should be near neutral pH at 6.5. Strong base more than 10. Okay. So weak acid, weak base is not obvious. We can detect the equivalent point. So the pH change also uh, not obvious. So this is the titration curve for strong acid, strong base. If you still remember, the equivalent point is pH 7, and the pH range is between strong acid 3.5 to strong base 9.5. Okay, pH range. Uh, the graph is so steep at the point where no different in volume of acid added, whichever indicator you choose. So the volume uh, is no on the similar volume. Okay, it range of pH, the different pH, the volume is the similar. So this is the character of titration curve for strong acid, strong base. The graph step. So you can see neither indicator, no indicator change color at the equivalent point, because the strong acid and strong base, the equivalent point is 7. So the no indicator will show the color changes at the equivalent point. As you can see, the equivalent point is colorless. However, it makes sense to titrate the best possible color with each indicator. For example, if you want to use phenolphthalein, you would titrate it until just become colorless, meaning that it's just in the border. So from purple into colorless, or from colorless into purple. Okay, at pH 8.3, because this is the closest you can get the equivalent point. If you want to use the metal orange is the indicator, you would titrate until there is a very fast trace of orange in the solution. Okay, so it can be happen about 5 or 4 or pH 5. If the solution is become red, you're getting further from the equivalent point. So meaning that if the solution is very dark orange, so it's very far from the equivalent point. All right. Uh, okay. So this is an example of strong acid and strong base titration, HCl and sodium hydroxide. So when you do the titration, the sodium hydroxide will react with the hydrochloric acid to produce sodium chloride. The sodium Na plus will combine with Cl minus, and OH minus will combine with H plus. So as you can see, the product is sodium chloride and also water. So at the equivalent point, the hydroxyl will react with proton or hydrogen to form H2O. So titration of strong acid and weak base. So the equivalent point of strong acid, meaning that equivalent point Uh, if you still remember, equivalent point, pH should be less than 7 because it's a strong acid. So the pH range is about a strong acid, I think it's about 3 until weak base is about 10. Okay. Uh, weak base is not 10, it's less than 10. Uh, uh, weak base is about 7 because it's a weak base. So about 7. 3 until 7. Okay. All right. So the phenolphthalein would be completely useless because as you can see the equivalent point where the indicator will change the color, the equivalent point is less than 7. If we want to use phenolphthalein as an indicator, we cannot observe the color changes. It's because it's very far away from the equivalent point. So the only option that we can have is a metal orange. When we use a metal orange is the indicator in the titration of strong acid and weak base, the metal orange will start to change from yellow to orange. So as you can see, the intensity of color from yellow to orange. Uh, close to equivalent point. So hydrochloric acid and citric acid titration is one of the example of strong acid with base. Okay, so strong acid, the proton will be react with ammonia because it's a weak base. So the equivalent point less than 7 because so it is a reversible reaction. So if you want to titrate a weak acid with strong base, so the equivalent point is strong base is a pH more than 7. So pH range, weak acid towards the neutral, 6 until strong base is about 10. Okay, we check. It's 6 until 10. Okay, 6.5, 10.5. So this time, the metal orange is hopeless. We cannot use the metal orange because the metal orange is further away from the equivalent point. The equivalent point is above pH 7. So we can use phenolphthalein. The phenolphthalein change the color exactly where you want it to. Okay, it's within the purple band, color band. Okay, so this here are example of weak acid, strong base. Okay, so uh, strong base should be hydroxide react with acetic acid. So the equivalent point pH above pH 7. Okay, so this is a reversible reaction. So titration of weak acid and weak base, the equivalent point is what is it? It's not possible. It's impossible. What is the term? not obvious, sorry. So for the titration of weak acid in weak base, the equivalent point is not obvious. And the pH range also is not obvious. So the titration curve is for a case where the acid base are both equally weak. Neither indicator it can be used. On the whole, you would never titrate weak acid with the weak base. Okay, in the presence of indicator. So this is the summary of titration curve for strong acid, strong base pH 7, strong base, weak acid above pH 7, weak base, strong acid below pH 7. The equivalent point, weak base, weak acid is not obvious. So I think I stop here for this video because the next video will a lot of calculation. So I stop it here. So see you again on the next video on the quantitative analysis. Okay, bye bye. See you again on the next video.